All right, folks, are you ready? Raise your hand if you're ready. I see you're listening as well. Thank you very much. That's great. Not just studying your phones. So yeah, we are about to get ready, reset, go. Resetting the quality of recycled plastics. Now, I work for a company that is focused on creating a healthier planet for our children. That company is called Neste. My name is Outi Teräs. I commercialize chemical recycling technologies, and you're about to hear more about them in a bit. But first, let me talk a little bit about Neste as a company. These are some of our products. So we work on road transport. We work on aviation fuels. Our specialty is renewable fuels. But what we also work on is renewable and circular solutions for the petrochemical industry. We reduce dependency on fossil resources and accelerate circular economy. Of course, here, the circular solutions, chemical recycling plays a big role. So that's what we are talking about here. I'll do another one, hands up. How many of you studied high school chemistry? Raise of hands. Almost all. Very good. Well, I have to say, I did study some chemistry at the university as well, but I knew nothing about plastics when I came to work at Neste. And I actually had to Google what a polyethylene molecule looks like. And to those of you who didn't recognize, that's what it is. Now, when we talk about decarbonization, those of you who went to high school chemistry know that the C here stands for carbon. So how do you decarbonize polymers? How do you decarbonize plastics? You don't. You defossilize them. Neste's vision for a more sustainable future in polymers and chemicals is that we are defossilizing the carbon. We are replacing fossil carbon with carbon from renewable or recycled streams. So taking away the fossil from the lithosphere and replacing it with recycled from the technosphere, renewable from the biosphere, maybe someday also carbon from the atmosphere. But today, this is where we are. This is already true. Neste accelerates the transition to a circular bioeconomy. So the two rectangles here are the areas where we are active. We are providing renewable raw materials to the petrochemicals industry. So that's the green box. And we are also working on chemically recycling those polymers back to the circular economy. So that's the blue box. Our end product is a drop-in raw material for the petrochemical industry. Our brand is Neste Re. Re stands for renewable and recycled. And our aim in this value chain is that we are able to solve the quality problem for everybody else. So what we provide to our customers is a drop-in product that enables them to use existing assets, existing infrastructure, without big investments, to produce more sustainable polymers and chemicals. Since the hydrocarbons that we provide are typically going into durable plastics, they are also fully compatible with recycling infrastructures. We have seen some bio-based polymers out there which are biodegradable, compostable. And of course, these can't be brought back into circular economy. But when you are using the bio-based or the circular raw materials to produce plastics like polyethylene, polypropylene, these are already collected and recycled in industrial scale. The technologies exist. So our thinking is we are able to make to close the loop and to make it work. But since we can't bring back 100% to the cycle, that's where the renewables come in. So whatever unavoidable losses we have in the recycling part, we are able to replenish the cycle with the renewables, thus contributing to the defossilization. Why chemical recycling? I was at a conference 2 weeks ago where everybody was working on chemical recycling. We didn't spend a lot of time on this slide. I felt like I was preaching to the choir. In this trade show, I might not have all converts in the audience. So why we are doing this, we want to increase the recycling rates for plastics. We are targeting streams that have no place to go in mechanical recycling, that today end up in incineration or landfill. And by recycling those streams back into the circular economy, we want to contribute to increasing the recycling rates. We are also reducing dependency on fossil resources. As said, target is to defossilize, accelerating circular economy. And the best part is, after the recycling process, the end products, the quality is equal to conventional plastics based on virgin materials. So we are able to reset the quality of plastics in this recycling process. So there are the advantages of chemical recycling. I'm going to be focusing on the first one a bit more. How can we increase the recycling rate of plastics? Because I know there might be some skeptics out there. This is our raw material. Another hands up, how many mechanical recyclers do we have in the audience? Any? We have one. One brave soul. Okay, thank you for joining. Well, those of you, the one who works in mechanical recycling, knows that this material is not easy to use as raw material for mechanical recycling. So the first picture there, this is post-consumer plastics, quite contaminated with paper. There might be some sticks of wood. There's some mattress in there. So this is not mechanically recyclable raw material. This is material that went through our recycling system and came back as drop-in raw material for new plastics. The middle picture there, this is cross-linked polyethylene. Post-industrial waste, yes, but since it is cross-linked, it's not mechanically recyclable. Cross-linked polyethylene is a thermoset, cannot be processed, like re-melted in the mechanical recycling process. But this as well came back as raw material for new plastics, actually went back into the same pipes where the raw material came from. You can see some samples at our booth. The last picture there, that's extruder purge from mechanical recycling. And that is a mix of different polymers. So it is already a reject from mechanical recycling. These are some of the materials that we are bringing back into the circular economy through chemical recycling. And of course, there are many more. So we are targeting hard-to-recycle streams. It might be multi-layer plastics, in some places even colored plastics are an issue. And in addition to these examples, like the cross-linked polyethylene, for example, Recently, we tested also discarded tires as a raw material. So discarded polymers is now quite a broad range of things. We see that by targeting these streams, there is a high potential to increase, and as we estimate, even double the amount of plastics that go back into recycling. And of course, this will still not cover 100%. So in addition to mechanical recycling and what we call the liquefaction route, chemical recycling through pyrolysis or hydrothermal liquefaction, for example, we will still need other technologies. It could be other chemical recycling technologies, depolymerization, gasification, for example, so that we are able to still increase. But already the liquefaction route would be doubling the quantities here. Neste is focused on the liquefaction route. Was already a bit referring to this earlier. So chemical recycling is not a monolith. It's a group of different technologies that are addressing, I would say, different waste streams and also targeting different end product mixes. In our case, we start with liquefaction, which could be pyrolysis, it could be hydrothermal liquefaction, it could be thermolysis, so terminology varies, but what comes out of a liquefaction process is something that resembles crude oil. And this is something that we can then refine further into a drop-in petrochemical raw material by using oil refining assets that were originally intended for crude oil refining. Now, why is this intermediate refining step needed? After the liquefaction, the oil that comes out, pyrolysis oil, HDL oil, it still contains a number of contaminants. So from the perspective of our customers, anything other than carbon and hydrogen is a contaminant. We need to remove those. That's what we do in refining. The oils are also relatively unstable, so we need to stabilize them. And they contain a heavy fraction, which is not in and of itself feasible to use in petrochemical processes. So in an oil refinery, we can recrack those heavy fractions and make more of the light fractions, which are designed for petrochemical end uses. So this is what happens in chemical recycling according to Neste. And all of this is to reset the quality, is to take those difficult to recycle streams and bring them back into high quality raw materials. We've been doing this since 2020. And as you can see, these are not marketing photos. So the raw materials that you saw in the earlier slide, what was produced out of them was this ugly, really dark brown liquid that smells bad and is quite dangerous to even handle. What we are able to do is to turn it into that liquid on the right-hand side, a clear liquid, in this case a naphtha liquid, that is a drop-in material for the petrochemical companies. We've been on this journey for quite a long time. We started the research in 2015, and already in 2018 we felt comfortable enough to announce our 1 million ton target. We want to chemically recycle more than 1 million tons per year as we progress on this journey. We're not quite there yet. But we have already made really significant steps in this direction. So in 2020, we started refining these oils in our oil refinery in Finland. And as we speak, we are investing in new technology and new assets developed by Neste, proprietary to Neste, in our EU Innovation Fund-backed Project Pulse. So this is our a project that implements these new technologies into the existing refinery and aims to increase the quality, flexibility, as well as the quantity that we are able to process. I have a slide on Pulse coming up. And this is already a project that is underway as part of the Porvoo refinery transformation. And you'll hear a couple words about that coming up as well. In the lower part of the slide, some more about our collaboration with Altera Energy. So we invested in Altera in 2020. We have collaborated with them on technology development ever since. And in 22, we acquired the European rights to Altera's technology, and we are currently licensing that to our partners in Europe. Altera is a very robust liquefaction technology based on a rotary kiln pyrolysis. But let's not get too technical. What you need to know about Altera is that it is robust enough to manage the mechanically unrecyclable waste while still maintaining high operability and reliability of the technology. Feedstock flexible, energy self-sustainable, so the non-condensable gas from the process is used as the main energy source in the liquefaction step. Proven at scale, so the picture you see there is from the commercial reference plant that Altera has in Akron, Ohio, in the United States. So this technology solves our first headache in bridging the quality gap from the mechanically unrecyclable waste to a drop in petrochemical feed. The first problem are the macro impurities. So the mixed plastic stream contains paper, contains biomass, carton, wood, whatever sand there might be. And you need to have a liquefaction technology that is able to manage these mechanically unrecyclable streams with good reliability. Now the second part is then what happens to the micro impurities. So the contaminants still embedded in the oil after the liquefaction step. And this is where our project Pulse comes in. So Neste is investing in new capacity for processing these oils. And our aim is that we are able to broaden the range of plastics that can go through chemical recycling by addressing those contaminated streams. So these are the technologies that we need to remove the contaminants, as we spoke, stabilize the oils, recrack the heavies, to produce that drop-in raw material for new plastics. As we see it, there are a number of technologies already out there for processing these oils. But the most cost-efficient way, as well as the most environmentally friendly way to process, is to use what you already have. So we have existing refinery assets, and we need to tweak them. We need to add some technologies to those refinery assets to ensure that we broaden the range and increase the quantity of oils. But we are very efficient using resources when we use the existing refinery assets already. We're already at work. So the final investment decision for the first phase of this project Pulse was done already a year ago. So we are in construction as we speak. Target is that next year we are able to start up the first phase. The first phase will get us a capacity up to 150 kilotons per year. And the whole Pulse project is aiming at 400 kilotons of capacity. So it's not quite yet our target for the 1 million tons, but it does get us halfway. And this project is supported by EU Innovation Fund. And of course, for us, this was a big nod 2 years back when we got this grant from the EU. It is a significant sum of money. I'm not saying that that isn't important. 135 million reasons to be happy, but the political support in this situation is even more important, if you ask me. So the nod to chemical recycling technologies, that EU has confidence that these are technologies that can lower the carbon footprint of products. The refinery transformation in Porvoo that we mentioned is already going on, was announced last year, and this is a massive project. But we are committed to turn our final remaining fossil asset into a refining hub for renewable and circular materials. The exact date when this should be finalized is not known yet, as everything is depending on investment decisions as we proceed. But the aim is that by mid-2030s, we would be there. And of course, Neste is already committed to have carbon neutral production by 2035. So this project helps us also with that target. In summary, we are turning plastic waste into a valuable resource. And in doing that, Neste's part in this value chain is in the middle, in the green arrow. But of course, we need to work together with the whole value chain to develop our ability to process low-quality waste, to ensure that we have efficient logistics and safe logistics as well, robust technologies, as we discussed, the drop-in offering to the petrochemical partners, as well as then the sustainability and transparency in the value chain. We are looking for partners. We're interested talking to you, especially if you are assessing opportunities in chemical recycling. We are able to provide technology, so that's one area of potential collaboration, that we are able to provide liquefaction technology to those of you considering to build assets. If you already have a technology and are constructing assets, we are still interested in talking to you because Neste works with a number of suppliers, and we are, I would say, quite a flexible off-taker of those oils. So please come and discuss with our supply experts. And if you are in the petrochemical space and you're looking to make plastics more sustainable, we're also happy to work with you with our end product, Neste renewable and recycled hydrocarbons. So meet us. We are in this hall, down that corridor, F1. Just think of Mika Häkkinen and Kimi Räikkönen and all the other Formula One. I guess Max Verstappen would be the local reference. So you'll find us there for more questions and discussions. I think we are running out of time here, but in case any questions have arisen, meet us at the booth. Thank you.